Hi there, this is exercise 7D. We're going to look at the area and lengths of sectors and segments and arc lengths. But I'll just give you a guide to this from GCSE, because this really was something you did see at GCSE. So if I was to draw a circle, we obviously know it's got two formulas, pi r squared for the area, and it's got pi times diameter. It's actually probably better written as 2 pi r for the circumference. And those two formulas are useful if you get told you've got part of a circle. So say I get told that I've got, I don't know, I'm going to say 110 degree angle, and I want to know the area of this section, and also its arc length, which is this section here. So I could work out the area, and basically the idea is you do 110 out of the 360 degree angle times by what pi r squared is. Well, let's make up an r. R now is 4 centimeters. So pi times 4 squared. And you can quite simply do that, and it gets you a nice answer. And to be honest, there's nothing stopping us doing this at A level, apart from just typing this in as I've done it. So I've done that, and as a decimal I get 15.3, 15.4 square centimeters. Hopefully you get the same. There's no problem with us doing this here, apart from there's a quicker method, and it's this quicker method that I want to do. Now the circumference was the 2 pi r. I've written that again because it's unusual to write it like that for GCSE. You tend to write it as pi times diameter, but of course 2 times the radius is the diameter, so it's the same thing. Now our arc length in this case is a proportion of that, and of course it's 110 out of the 360 as a fraction of the whole circle, so times by the 2 pi r. Actually the 2 and they kind of cancel if you want them to, but who cares? So I'm just going to type them in. 110 divided by 360 times by 2 times pi times r, which was 4, and again I get 7.68 centimeters. So it's that kind of stuff that we're doing today, but now our sector is going to be measured in radians, and that's the big difference. What I've done here is I've given you an angle in degrees, and of course at A level you expect to be able to do the same thing in radians. So let's have a look. A quick question first. It says a vinyl record, these are those old-fashioned records, makes 100 revolutions in 3 minutes. Well, first of all, one revolution is obviously 360 degrees, and I know that 180 degrees equals pi radians. So just bear that in mind. It does it what's it say? It says it does 100 revolutions. So 360 is twice this, so I reckon one revolution is 2 pi, and I do it 100 times. So I reckon that basically gives me 200 pi radians, and it does it in 3 minutes, which is 180 seconds. So if I want to know how many radians it turns, I'm going to do 200 times by pi divided by 180. So this is 200 times by pi divided by 180, and I get 3.49 rads per second. 3.4 rads, that's right. And the other one, this is another vinyl record, is placed on a turntable that makes a complete turn in 1.42 seconds. Well, again, a complete turn is 2 pi radians. So if it does it in 1.42 seconds, if I divide that by 1.42, it'll give me the angular speed, which is again radians per second. So I'm just doing this to get us used to, again, well, a vaguely real life question about radians, and getting us thinking about degrees and radians and the equivalences. I get 4.42 here when I've done that. Let's see what the answer says. 4.42 rads per second. So now we've got that, let's do a bit of a proof for the formulae that I want you to learn. So set it up as you would expect. I've got a couple of emails hit me there. A couple of things to note. We've got the arc length here. I've called it L. This is an L. we've got the angle for this sector is theta. There it is. Obviously it's normally 2 pi all the way round, but for our sector it's theta. And we've got the radius there, r, for our sector. So I've said, here's a little formula, and it's really all we did last time. Last time we did the angle divided by 360. Here this time I'm doing the angle divided by 2 pi, because now we're in radians. But the great thing about this is that 2 pi cancels that 2 pi. That's why it's such a great formula. And you're actually only left with the r and the theta. And we write that as L equals r theta. This, if you get measured, angle measured in radians, to work out that length, you just do r times theta. I also want to know its area, so I've now got a formula for its arc length. I want that area formula. We do a similar thing. Area of a sector, we do the angle. Last time we did it, angle divided by 360. Now it's a theta over 2 pi. But you can see the pi's cancel. I've still got an r squared, I've still got a theta, and I've got an over 2. So our formula is a half r squared theta. These are the two formulas that we are meant to know off by heart. So those two formulas, make sure you write them down, and we're going to do some questions on them now. So first of all, find the arc length L and the area A of a sector of circle of radius 7. So I must have, it says it's a sector, I'm going to draw the same picture every time. I don't really care how big it is, what the angle is. It says the radians, it's 2 rads there, and it's 7 centimetres there. So okay, this is dead easy. Arc length, could have just written L equals r theta, so that's 7 times 2, which is 14. How easy is that? Centimetres, because it's a length. The area of the sector is now a half times the r squared, all times by 2. Remember the formula is half r squared theta. So 7 squared is 49. The 2's kind of cancel, so this is 49 square centimetres. That's an area. And there we are. Now how easy is that? That's what you're meant to be able to do. And there are other versions of it. Find the arc length L and the area A of a circle of radius 5 this time. And this time it says the angle is 150. Well, the first thing I want to do really on this one is I'm going to change 150. I'm going to divide it by 180 and times it by pi. And basically that tells me that 150 is 5/6 of pi when you change it into radians. So that's how many rads I've got. So they've given me an angle in degrees. I'm determined to use this formula because it wants the answer in terms of pi. So what's that mean in terms of this? My angle is 5/6 pi. My radius is 5. L, my arc length, is r theta, which is 5 times 5/6 pi, which is not very nice, 25 over 6 pi, but it wants it like that, so there you go, centimetres. My area is a half r squared theta, is a half times by r squared theta. And I reckon if you do this, you get, that's 125 there, 125 over 12. I don't suppose that simplifies at all. And it's not very nice, but that's what they want, so that's what they've got, and yeah, that's the answers. Couple of backward examples. So let's do A first of all. Find the angle of the sector of circle with radius 4 and arc length 12. Okay, so again, just draw the same picture every time. 4, 4, and this time they tell me this is 12.4. So I want the angle theta. Remember, L equals r theta. So 12.4 equals 4 theta. And theta, therefore, is obviously the 12.4 over the 4, which I would have said is 3.1 radians. Nothing like I've got in my picture, but you get the idea. 3.1 radians, I'm just trying to, in my head, work out that. It's about 150 degree angle, I suppose. I remember one radian is about 57. Anyway, part B, we've got another. It's got an area of 14.4 It's got a angle there of 3, and it wants the r this time. Okay, so again, area equals a half r squared theta. Area is 14.4. That's equal to a half r squared. I don't know the r times 3. You can see I'm just going to move it around, and that moves up to the top. That moves down to the bottom. I get 14.4. Let's do this. 14.4 times by the 2 divided by the 3. I get 48 over 5, or if you want as a decimal, 9.6. So therefore r, obviously I'm going to square root the 9.6. Square root will be equals, I get 3.098, so 3.10. 2, 3 significant figures. Good, 3.1 rads and 3.10. Pure fluke that they're saying all this very similar. Look, so you're going to now do some questions. Question 5 onwards I've suggested, exercise 7D, and I think they're fairly straightforward. I don't think you have too many difficulties with them. Best of luck.